have the Tesla coil itself. And the Tesla coil, you plug it into the wall and it takes in the AC current, the voltage, and it amplifies it very quickly in slow increments until it has the breakout point here where it breaks out to ground in order to complete the circuit. And if we take this off, inside we have the different components here. We have, this is for the fiber optic cable. We use the fiber optic to receive and send, well, to receive signals from the interrupter because it's a non-conductive, it's just light signals, so it can't arc to that, causing any problems. And then we have the ICs here, which help the IGBTs, the gate drivers, to switch, because the way the Tesla coil works is very much like a swing set when you were a kid. And in order to get it to go higher and higher, you have to push when you're going up, and you don't want to push when they're coming back, because then you just get knocked over. And the same thing is with the Tesla coil. We need the gates to switch right when the current is at, the voltage, sorry, is at 0. That way it's not pushing against itself. It's not trying to fight against, you know, the voltage it's already created. And by doing that, it builds and builds until eventually, with this breakout point on the top, it'll break out, causing that spark that you see here, and which creates the sound.
Okay, so I wanted to explain a little bit about how the singing Tesla coil actually sings. The way it does this, every time the Tesla coil builds up enough voltage to let out a spark, that spark causes a pressure wave off this breakout point that radiates outward. And when it's picked up by your ears, if enough of them come within a second, it can actually sound like a note. For example, if the Tesla coil were to release a spark 440 times every second, your ear would register that the same as a piano note A. And so this piece of equipment, the SD card interrupter, actually takes in either a live MIDI feed from a piano or other MIDI instruments, or from an SD card with preloaded songs. It interprets those MIDI files into what frequencies they are and what PWM signal it needs to output to the Tesla coil in order to accomplish those notes.
So this is our Faraday cage, and we built it with acrylic on the outside so you could see it, and we put in air holes on the top. You can see right there, so that we could allow for a fan we put underneath so we could vent out all the ozone or whatever else might have been in there. And so we could also hear it. And then the mesh on the inside was designed to be like a Faraday cage, like in Sorcerer's Apprentice, where they were protected from it on the inside. We're trying to protect everybody on the outside of the sparks that were occurring from the Tesla coil. And at first we were testing it outside of the Faraday cage to see that it was functioning properly. But then when we tried it inside, it was working before on the outside, but when we put it inside, we think we fried something, and we're pretty sure the reason is because the mesh that we had on the bottom basically allowed the spark to be able to go back into the coil and fry something a lot faster than it would if we had it outside of the cage, because this is all conductive material on the outside. So that's our probable cause for it not working anymore.